Next up on stage, we have from the Department of Chemical Engineering. Please welcome Sean Thornton.
What if we lived in a world of limitless electrical energy? Many of the world's greatest problems stem from a lack of energy. Sadly, a great number of people around the world still don't have access to it, especially in developing countries and remote areas. Providing energy to these people can greatly enhance their quality of life. Energy powers many things like hospitals, water treatment plants, lights, travel, and everything in between. Our current main source of energy is fossil fuels, which are non-renewable. That means we will run out eventually. Not only that, fossil fuels cause environmental issues, especially climate change and pollution to our air and water. It's clear that to satisfy the ever-growing demands for energy globally, renewable energy sources are the key. There are many sources of renewable energy, including wind, geothermal, and hydro, among others which are important. The most promising source of energy is something that lights up all of our lives every day. It's something we can't live without. Something so big and powerful it heats up the Earth from 148 million kilometers away. I hope by now you've guessed what I'm talking about. The sun is a massive ball of energy accessible all over the world. It provides enough energy in 1 hour to satisfy the entire world's yearly energy demand. It's clear that deploying solar energy sources all over the world will be the next great leap forward for humanity. A solar cell is basically a device that takes the sun's energy and converts it into electricity that we can use. Typical solar cells using silicon are expensive and take lots of energy to make. I'm researching the next generation of solar cells. My research is focused on a material called perovskite, which shares the same crystal structure with the compound calcium titanium oxide. Perovskite is cheap and easy to make. It's only been researched for several years as a solar energy material. Despite that, it can harness solar energy nearly as efficiently as conventional solar cells already. In theory, it can be even more efficient. Amazingly, perovskite can also be transparent and quickly and easily deployed over large surface areas. Right now, the most efficient perovskite is not green because it uses the heavy metal lead, which is incredibly toxic. My research focuses on making perovskite green by taking the lead out and replacing it with more benign chemicals. Once we have a green perovskite, we can employ it everywhere, harness solar energy, and make green energy for everyone a reality. Thank you.